Hey guys, welcome back to Miss Marcuson's kitchen for another lesson. One thing that we've talked a little bit about is I'm renovating my house. That's why you see things like this and nasty green paint. Maybe with some extra time during this safer at home quarantine, I might get a chance to paint and do some work, and maybe I'll show that off to you guys. So excuse the weird looking ceiling stuff. But today's lesson, if we get to it, is going to be about tape diagrams. Now, it doesn't actually involve tape, it just kind of looks like it involves tape. And what a tape diagram is it's simply a strategy to help us solve ratio problems. We've talked about how a big thing in math is staying organized, and that's kind of what a tape diagram helps us do. It's going to take a ratio, it's going to make it visual, and it's going to kind of show us how we can solve a problem. So, today's problem is I was cleaning out my kitchen cupboards, and guess what I found? Christmas M&Ms, Alright, so I bought these, clearly didn't use them for a treat, but I bet you guys didn't know this. Christmas M&Ms come in a ratio of red to green M&Ms. And they give you more reds, because clearly those are the better tasting M&Ms. And trust me guys, I did not write this on the bag. I mean, it was totally there. I must have bought it that way and not even realized it. I mean, perfect example of ratios in the real world. It says it right there. It's on the bag, so it's got to be true. So anyway, today we are going to be solving some problems using kind of red M&Ms and green M&Ms, and I'm going to show you how we can make tape diagrams to kind of organize this information. Alright, so let's examine the ratio of red to green M&Ms 3 to 2. What does that mean? Well, using good ratio language, we can say that for every 3 red M&Ms, there are 2 green M&Ms. So let's look at that visually. What that means is if I have 3 red M&Ms, I also have 2 green M&Ms. Okay? And then that's our root kind of ratio. But we always know that ratios can be made bigger. Unfortunately, in a ratio, I can't just add 1 red M&M and 1 green M&M because that's not going to keep our groups all the same size. And that's the thing about a ratio is it's 3 parts red, 2 parts green, so it needs to always maintain that. So what this actually looks like is as I need to add 1 to all the reds, and I need to add 1 to all the greens. Okay? And then the next time I want to add more to this ratio, I would add 3 reds, and I would add 2 greens, or 1 to each green. Okay? And then we're just going to keep doing this, and then that just keeps making these ratios equivalent, because what I do to one, I do to the other. Now, here's what a typical ratio problem is going to look like. Is they'll tell you this ratio, 3 reds for every 2 greens, but then they might hide part of it from you. And they'll say, well, you have 12 reds. So how many greens do you have? And what you'd have to look at is, well, in order to get those 12 reds in my 3 to 2 ratio, I'd have to have how many in each group? And in this case, it's 4 in each group, which means you'd also have to have 4 in each group of your greens, and 4 times the 2 parts green means you have 8 greens. Now, we don't always have red and green M&Ms in front of us to solve these problems, so that's where a tape diagram comes in. To make a tape diagram, I'm actually just going to take these groups that we naturally set up and make in our ratios, and I'm just going to kind of create rectangles around them. Okay? I'm going to split each group into its own. I'm going to do the same down here. Okay? Notice how those rectangles kind of make it look like it's got little pieces of tape. Now, it's very important that we always label our tape diagrams. So I'm just going to put an R for red and a G for green. Okay? Now, in a tape diagram, we have to really think about where pieces of information go. So I'm going to take these M&Ms out. Okay? And then we're going to examine kind of a similar, simple case. Consider this for our next problem. We have our tape diagram, and we're going to use that just so we kind of know where to place our M&Ms as we go through this. I have a ratio of 3 to 2, red to green. And I have, let's say, 60 M&Ms. So I'm going to kind of do a time lapse for this, and you're going to watch kind of as I organize those out. And then we'll talk about an easier way to do this later on. All right, and here's our end result. I took our 60 M&Ms and a ratio of 3 red for every 2 green, and I split them into our tape diagram. Now, the first thing you might notice is, man, this is really messy. Like, this is hard to do. And we don't even always have these counters to kind of count through. But if we kind of take a look, and I think I've divided these correctly, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 reds in each square, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 greens in each square. Now, I'm not going to count the other ones, but they're all going to be the same. So essentially what we've done in this tape diagram is we took our 60 M&Ms and we split them into how many parts? 5. And we get those 5 parts as well because if our ratio is 3 to 2, we can add those together and we know that we have 5 parts. We have 3 parts red, we have 2 parts green. So we took our 60 M&Ms and we divided it into our 5 parts, and that tells us how many are in each part? 12. So our last step in figuring out how many of each color we have is to take 12 in each part and multiply by how many parts there are. Well, in red, there's 3 parts, so 3 times 12 is 36, and in our green, we only have 2 parts, so 12 times 2 is 24. Oops. And as a double check, if we add these together, hey, look, that's our 60 again. So what's our final answer to this problem? Well, if we have 60 M&Ms out of our ratio of 3 to 2 M&Ms, red to green, we would have 36 reds and 24 greens. Now let's talk about this without the M&Ms. Okay, so let's say we are approaching this very same problem with just a tape diagram and not using manipulatives or M&Ms to help us make sense of it. So we are looking at the same thing. We have a ratio of red to green, and our initial ratio was that 3 to 2. So I'm going to draw. This is how I like to. Now you can draw individual rectangles, but I just start with one long rectangle, and I know that red has 3 parts from our ratio, so I just split that rectangle into 3 parts. And then when I go to do green, which only has 2 parts, I'm going to purposely make the green rectangle only as long as the 2 parts for the red. So it doesn't have to be perfect, but they're similarly sized. All right, now in a tape diagram problem, you are always going to have one more piece of information. And in this case, they told us that we have 60 M&Ms total. Okay, so this one right here, this is the red part, this is the green part. I like to put a line down here, and this is where we kind of put our total. Because I know I have a total of 60 M&Ms made up of red and green M&Ms. Now, what's the next thing we do? Okay, well, since 60 is our total M&Ms, and we know it has to abide by this ratio of 3 to 2, okay, we're going to take these 60 M&Ms and we're going to divide them amongst the 5 parts of our ratio because there's going to be 3 parts red and 2 parts green. So you will always have a division problem kind of in that next step. And in this case, it's 60 divided by 5 because, again, 60 is our total, and we have a total of 5 parts. 60 divided by 5 equals 12. That is what each part is equal to. Okay? And then now I can solve and go, well, 3 parts are red and each part's worth 12. 3 times 12 is 36. And if 2 parts are green and each part is worth 12, 12 times 2 is 24. Just do a double check to add. Hey, that works. I have 36 red M&Ms and 24 green M&Ms. All right, let's examine this next problem. So let's say we bought a different bag of M&Ms, and this time our ratio of red to green M&Ms is 4 to 3. And then our next piece of information is that we've already counted and we figured out that, well, we have 32 reds. So if the ratio is 4 to 3 of red to green and we have 32 reds, we're trying to figure out how many greens do we have. And we're going to do this without counting. So I'm going to set up my tape diagram, I'm going to label my reds and my greens. And we always take that ratio and we're just going to draw it out visually. So red, the first is going to get 4, green is going to get 3. So I'm going to start that with just my rectangles. Okay, 1, 2, 3, 4. Green gets 3. 1, 2, 3. Okay. Now we need to put in our next piece of information. Now, in the last problem, we knew we had a total of 60. This time we don't know the total. This time we know how many reds we have. So we're actually going to put that just right at the end of the reds. Because that's what 32 corresponds to the reds. So when we go to do our division problem, it's going to be a little bit different this time because, like I said, last time we had a total, so we divided by our total parts. This time we have how many reds we have and how many parts make the reds. 4. Only 4. We don't include the 3 here because the greens don't make up the 32 reds. Okay, so we are going to do, our division problem is going to be 32 divided by 4 because we're going to take these 32 reds and sort them into the 4 parts. 32 divided by 4 makes 8. So inside each of these boxes is 8 red M&Ms technically. Now, if the parts for the reds equal 8 in a ratio, that means the parts for the green are also each worth 8 because in a ratio it has to be the same. So if we want to figure out how many greens we have, our last step is simply going to be 8 times 3 to find how many green M&Ms we have. All right, for our final example problem in this lesson, I'd like you to pause this video after I explain the problem and try to solve it yourself. Try to make a tape diagram. So for this problem, we have a ratio, we're in a new bag, we have a ratio of red to green M&Ms is 2 to 5. Okay, for every 2 red M&Ms, there are 5 green M&Ms. We have a total of 28 M&Ms. Okay, that's our total. How many of each color do we have? So please pause your video now, try to draw out your tape diagram and solve this problem. I'm going to go ahead and begin solving now. Hopefully you've solved already. I'm going to start by labeling my tape diagram, reds and greens still, staying with the original ratio, red to green, red to green. I know that there are going to be 2 parts red and 5 parts green. Okay. Our extra piece of information was the fact that there are 28 total M&Ms. So that 28 does not go with the red, it does not go with the green, it's a total of both of those. And I'm sorry, I know you can't see that exactly. The way I've got my iPad set up is a little goofy, so there we go. All right, so what division problem do we need to do for this problem? Well, since 28 is a total, we need to divide by the total parts. If we count them, we have 7 parts. So 28 divided amongst our 7 parts means that there would be 4 M&Ms in each part. Okay, we can put that in there. And then the last step is multiplying it out. We'll have 2 parts of 4. That makes 8 red M&Ms. And then 5 parts for each for green means there's 20 green M&Ms. Okay. I hope this lesson helped. Please keep going on to the notes and to the practice. Let me know if you have any questions.